In this lecture, we will discuss Charles' law, which was presented by Charles in 1787. This law devised a direct relation between temperature and volume of a gaseous system. By increasing the temperature, volume of the gaseous system will increase, and by decreasing the temperature, volume of the gaseous system will decrease. But this direct relationship can be established under certain conditions. So let's have a look on the Charles' law definition. In isobaric closed system, volume of an ideal gas is directly proportional to absolute temperature. Volume of a gaseous system is directly related to the temperature when system is isobaric closed one. Iso means same and baric means pressure, which means pressure applied to the system must be constant one. And the system is closed one, which means number of moles within the system should also be constant. So a system should contain constant number of moles and should be maintained at constant pressure. Thirdly, the gas should be ideal one, which means the gaseous system should be maintained under ideal conditions. The pressure applied to the system should not be very high and temperature applied to the system should not be very low so that a gas can behave ideally. Fourthly, the temperature measurement should be taken in Kelvin scale, in absolute temperature scale. Then we can devise a direct relation between volume and temperature and a graph like this. And all the points under every condition of temperature will lie on this straight line, and we can say a volume and temperature have exactly direct relation. But if any of these is not fulfilled, then this straight line will not be obtained and volume and temperature will not have a constant direct relation. So this statement can be written mathematically as V is directly related to T. In order to eliminate this proportionality sign, we have to use a constant, and in this case we will use K. Students, constant is always multiplied with an independent quantity. By increasing the temperature, volume will increase. By decreasing the temperature, volume will decrease, which means temperature changes will lead to volume changes and not volume changes lead to temperature changes. In other words, temperature is an independent quantity and volume depends upon temperature in order to be changed. So, temperature being an independent quantity should be multiplied with a constant. So, this expression can be written V is equal to K into T. In order to find the value of constant K, this expression will become V by T is equal to K, which means V by T factor is always constant. If pressure applied to the system is constant, number of moles within the system are constant, gas is maintained under ideal conditions and temperature measurements are taken in Kelvin scale, then V by T will always remain constant. So let's prove V by T is equal to K by an experiment. Same, you have to make a closed system enclosing ideal gas maintained at constant pressure. 4 conditions must be fulfilled. Systems are closed one and maintained at constant pressure of 1 atmosphere. Let's say the initial temperature applied to the system is 283 Kelvin and 1 mole of the gas is enclosed within the system, and that 1 mole of the gas occupies a volume of 566 centimeter cube. Now what will happen if we increase the temperature from 283 Kelvin? Let's say we increase this temperature till 373 Kelvin. Now according to Charles' law, volume will increase and you can see here V2 has become 746 centimeter cube. The initial temperature was lower and final temperature was higher. Then initial volume was lower and final volume was higher, which means by increasing the temperature, volume has increased. Now let's calculate the value of K when the temperature was T1 and volume was V1. By replacing V by T with V1 by T1, and substituting their values, 566 divided by 283, you will find an answer of 2 centimeter cube per Kelvin. Now put the value of V2 and T2 in the same equation. You will again find an answer of 2 centimeter cube per Kelvin, which means by increasing the temperature, volume has increased, but V by T factor remains constant, which is according to Charles' law. And we can say V1 by T1 is equal to V2 by T2. Students, keep in mind this equation is applicable only when temperature measurements are taken in Kelvin, when system is closed one, when pressure applied to the system is constant, and when the gas is maintained under ideal conditions. That temperature applied to the system should not be very low and pressure applied to the system should not be very high. Then this equation holds. Students, Charles' law devised a direct relation between volume and temperature by keeping pressure and number of moles as the constant quantities. So if you plot a graph between volume and temperature by taking temperature along x-axis and volume along y-axis, we will get a straight line inclined to both v and t axis. This straight line is called isobar because it is taken at constant pressure. Students, a very interesting feature is associated with this graph, that isobar can never meet the origin. Why it can never meet the origin? Because temperature is taken in the Kelvin scale and origin has a temperature of 0 Kelvin, right? And this 0 Kelvin is called the absolute zero, where volume of the matter becomes equal to 0. And this absolute zero temperature can never be approached. Therefore, the isobar can never meet the origin. But it can meet the volume axis or it can meet the y-axis. How it can meet the y-axis? Let's translate this graph into the Celsius temperature graph. The graph number 2 is between volume and temperature in Celsius scale. Here origin contains 0 degrees Celsius temperature, right? So which can be approached. So when temperature approaches to 0 degrees Celsius, this straight line inclined to VT axis meets the volume axis, or isobar meets the volume axis, but it again does not meet the origin because 0 degrees Celsius is a temperature where volume should be equal to 0, but it cannot be equal to 0. Which means 0 degrees Celsius is not the coldest temperature which we have discussed in the previous lecture. That 0 degrees Celsius is not the coldest temperature, and at 0 degrees Celsius volume exists. Volume does not become equal to 0 at 0 degrees Celsius. If we extrapolate this straight line up to 273, minus 273 degrees Celsius, then volume becomes equal to 0, and this minus 273 degrees Celsius is translated in Kelvin scale as 0 Kelvin, or ultimately absolute 0. So minus 273 will be the temperature when isobar meets the temperature axis. But again, this temperature cannot be approached. So this isobar will not meet the temperature axis. Right? Students, in graph 1 and graph 2, pressure is kept constant. So what will happen if we increase the pressure, make it constant, and then devise VT relation? So here is the graph number 3 when pressure is changed from P1 to P2 and P3. Here P1 is less than P2 and P2 is less than P3. As pressure has increased, according to Boyle's law, volume should decrease. So this isobar at P2, P1, P2 and P3 will also be straight inclined to VT axis, but their location in the graph will be changed. When temperature is lower, P1, then a straight line more closer to volume axis is obtained. But when pressure has increased from P1 to P2, As pressure has increased, volume should be decreased. So this inclined line will be lower than P1, which is indicating the phenomena of compressibility. When we further increase the pressure to P3, the inclined line will be more lower than P2 and more closer to temperature axis, which is further indicating the phenomena of compressibility. So if we increase the pressure, the same straight line inclined to volume and temperature axis will be obtained, but its location in the graph will be changed and it will be more closer to temperature axis and more away from volume axis, indicating the phenomena of compressibility. Students, volume is affected by change in temperature according to Charles' law, change in pressure according to Boyle's law, and change in number of moles according to Avogadro's law. So what will happen if we increase or decrease the number of moles within the system? The graph number 4 is indicating the change in concentration of the gas within the system. If we increase the number of moles, or if we use a gas having the higher molecular mass, having the higher mass, in fact, the same inclined line will be obtained, but its location in the graph will be changed. But volume and number of moles have direct relation. So when you increase the number of moles within the system, the isobar move away from temperature axis and it will be elevated. If we change the number of moles to N2, then the isobar move away from temperature axis, and when we further increase the number of moles to N3, the isobar will be more away from temperature axis. You can see here that here when number of moles are N1, then at 0 degrees Celsius volume is lower and N2 volume is greater. For N3 volume is further greater than N1 and N2, which is indicating that when number of moles are increased, volume has been increased. And here, when pressure has increased, the volume at 0 degrees Celsius has decreased, which is indicating the phenomena of compressibility. So this was all about the graphical explanation of Charles' law. Why Kelvin scale was needed, why Celsius scale was unable to prove Charles' equation, and what is absolute zero. So let's discuss the very first question, that why Kelvin scale was needed. Students, let's have a comparison between Celsius scale and Kelvin scale. We have three scales of thermometry: Fahrenheit, Celsius, and Kelvin scale. So we will only discuss Celsius and Kelvin scale right here, right? So Celsius scale starts from 0 degrees Celsius and ends at 100 degrees Celsius. So 0 degrees Celsius is the coldest temperature on Celsius scale and 100 degrees Celsius is the hottest temperature on Celsius scale. According to Charles' law, if we increase the temperature from 0 degrees Celsius, volume will increase accordingly. By increasing 1 degree Celsius, volume will increase 2 centimeter cube, because volume and temperature have direct relation. So if a direct relation is between two quantities exists, by increasing one quantity, second quantity increases accordingly. If we increase 1 degree Celsius, volume will increase up to 2 centimeter cube. If we increase the temperature 2 degrees Celsius, volume will increase up to 4 centimeter cube, right? So this is a direct relation between volume and temperature. This was the expected direct relation between volume and temperature if temperature measurement is taken in Celsius scale. But it doesn't happen actually. The graph obtained was not accordingly. A straight line graph should be like this. Straight line should be obtained if two quantities have direct relation, and all the points for every condition of temperature and pressure should be on this straight line, inclined to x and y axis. So this straight line was not found for volume and temperature relation if the temperature was measured in Celsius scale, until and unless we introduce a factor of 1 by 273. If the 1 by 273 factor was introduced, then we can find this straight line. So a factor of 1 by 273 was a troubling factor. If we introduce this factor, we will get an exactly direct relation. But if we eliminate, if we don't consider 1 by 273 factor, then we were unable to find VT exactly direct relation, right? Secondly, if we increase the temperature, volume will increase. But if we decrease the temperature, volume will decrease. As coldest temperature on Celsius scale is 0 degrees Celsius, when the temperature approaches 0 degrees Celsius, volume should be equal to 0. But it doesn't happen. This was the second drawback of Celsius scale, that at 0 degrees Celsius, at the coldest temperature on Celsius scale, volume does not become equal to 0. So it means 0 degrees Celsius is not the coldest temperature. Then what is the coldest temperature? If we decrease the temperature further up till minus 273 degrees Celsius, then the volume becomes equal to 0, right? So this was the second drawback of Celsius scale. So keeping in mind these two factors, Celsius scale was converted into the Kelvin scale by a scientist known as Kelvin, where 0 degrees Celsius was made equal to 273 Kelvin and minus 273 was made equal to 0 Kelvin. And this 0 Kelvin, as I have discussed earlier, that minus 273 was a temperature, minus 273 degrees Celsius was a temperature where volume becomes equal to 0. So it is translated as 0 Kelvin in Kelvin scale. So 0 Kelvin is a temperature when the volume becomes equal to 0. So this 0 Kelvin or minus 273 degrees Celsius is known as absolute zero temperature, right? So let's prove by an experiment that Charles' law doesn't hold for Celsius scale but only for the Kelvin scale. Or if you are going to prove Charles' law with the Celsius scale, you have to introduce a factor of 1 by 273. Let's prove it by an experiment. In the previous lecture, we discussed an example of V by T is equal to K. Suppose the initial volume was 566 centimeter cube and temperature was 283 Kelvin and final volume was 746 centimeter cube and temperature was 373 Kelvin. As temperature has increased, volume has increased. This is according to Charles' law. Initially, temperature was 283 Kelvin. Now let's convert into the Celsius scale. As I have discussed earlier, that 0 degrees Celsius is equal to 273 Kelvin. So when you convert the temperature from Kelvin to Celsius, you have to subtract 273 from Kelvin temperature. So by subtracting 273 from 283, you will get an answer of 10 degrees Celsius. Same, when you subtract 273 from 373, you will get an answer of 100 degrees Celsius. So T1 in this example, in this experiment, T1 will be 10 degrees Celsius and T2 will be 100 degrees Celsius. Now put 10 degrees Celsius and 100 degrees Celsius in this equation. V1 by T1 is equal to V2 by T2, right? Volume will be the same, 566 and 746, but these two parts of the equation, both sides of the equations will not be equal to each other. You will not get the same answer on both sides. So you can simply say that V1 by T1 will not be equal to V2 by T2 if the temperature is taken in Celsius scale, which we have discussed earlier, that Celsius scale was unable to prove Charles' equation, right? So this equation needs modification, and modified equation for Celsius temperature or to prove Charles' law in terms of Celsius temperature, this equation holds, where Vt is equal to V naught into 1 plus T by 273. You can see here T is the temperature in Celsius scale and a factor of 273 has been introduced in this equation, right? And Vt is a volume at any temperature and V naught is a volume at 0 degrees Celsius. So this equation is used for calculation of volume when temperature is taken in Celsius scale, and this equation is used for calculation of volume when temperature is taken in Kelvin scale. Both these equations are interconvertible.